Dear friends, welcome back to my YouTube channel, Engineering Ninja. We are in the module called StaadPro for Beginners. We have already posted two videos for this module, where in the first video, we have introduced the software StaadPro. And in the second video, uh, we have detailed about uh, graphical user interface of the software StaadPro. I hope you'd be by now you'd be able to create different kinds of geometries using graphical user interface of this StaadPro. In today's video, we are just going to solve a beam problem using StaadPro. The beam details and everything, properties, all are given here. We have a cantilever beam, 5 meter span, 5 kilonewton per meter is the load. Cross-section details are given here. And we are going to use a steel beam, which is a modulus of elasticity of 2 into 10 power 5 megapascal, Poisson's ratio of 0.3. It's an elastic analysis, and we have already solved this type of problem using Abacus uh, in the module Abacus for Beginners. And we are trying to solve the same problem using StaadPro. Here we have manually calculated for a cantilever that is subject to this type of loading. We get the maximum moment of 62.5 kilonewton per meter. You can try it out. WL square by 2 is the formula, and you can calculate that as well. You can rather derive that. Similarly, we have a deflection formula for cantilever WL power 4 by 8 EI, where E is nothing but Young's modulus, and similarly I is the moment of inertia, that is BD cubed by 12 based on the cross section. So we have already calculated a moment and deflection analytically, and we'll be solving the same problem using StaadPro. Here we are. Let's create a project. Let's name it as beam, rather cantilever beam, and we are saving it this there's a default plugins where it's getting saved. Here it will ask you for which units you are going to use. It's by default it's meter kilonewton, and we are going to use the same. Next, and you have to finish it up, and then you will have the graphical user interface of the Abacus, and this is your drawing canvas where you are going to create your geometries. So today we have to create a geometry that's a beam of 5 meter length. So last time we discussed there are many methods or many ways of creating beam. We can use this grid, that's one way, and we can use this dialog box where we have to specify nodes X, Y, and Z. We have to create two nodes, then connect the new nodes with a beam element. But most of the times we'll be using this grid only to create. So let's snip on 0. I have snipped at 0 and snap, and another snap will be on 5. So I have created a line. For now it's a line of 5 units. Now I want this grid to vanish, to disappear. Here I can click on and I've created a line of 5 meter length. This is an isometric view. You can change the view. This is the front view, back view. We have already discussed these things in detail in the previous video. So we have created a beam of span 5 meter. If you want to also check this span, rather see the dimensions, you can click on here, display node to node distance. You have to click on the first node, and then it displays this 5 meter. And if you want to revert back, just click again. Go to node distance, click on this node, click on this node, and then that disappears. So we are done with the modeling part. We have modeled the beam. But this modeling also encompasses giving properties in cross sections. So this is just creating a geometry. Now, next step is go to the general, go to the property. Here is the property dialog box. So what is the next step? We have to give property modulus of elasticity of steel, that is 2 into 10 power 5 megapascal, and Poisson's ratio of 0.3. So what I need to do is you just define proper cross-sectional, that's a rectangular cross-section. Here we have a depth of, if you see, 0.4 meter or 400 mm and 0.3 meter. So 0.4 is the depth, that's meter, and 0.3 is the width. And I have just, if I go here, I have added the cross section, but I have not yet assigned it. By default, the material gets assigned is concrete. So we'll edit it. We'll say steel. Change. Close. Now we have created a steel material with a cross section of 0.4 into 0.3. Now I want to assign it to this beam. I can say assign to view. It will by default get assigned to whatever is the geometry that's in the canvas. Since there is a single beam, it will get assigned to the single beam. Assign to view, assign. Yes. Now this R1 section gets assigned to this beam. Right? Next thing is support. Let's create a support. Support, then this dialog box pops up. So create a support. We have to create a fixed support. Fixed, add. I have added a support. Now I want to assign it to this node. For that, I need a node cursor. It is by default, it gets activated. So I have to select this node, then assign to the selected nodes. Assign. Okay. I'm done with the properties. I'm done with the support condition. Next step is loads and definitions. What you'll need to do is you need to create a load case first. This is important here. Suppose when you are analyzing a huge structure, you have a dead loads, you have live loads, you have wind loads. So for each different type of a load, what you do is you create different load cases, just like a suitcase. You keep your loads in your particular load cases. But since here we have just a single load, we can create a single load case. It doesn't matter. Let's say it's a live load. Let's say live load. And now I have created a load case. I will just open this load case or this suitcase. I'll go to member load. I'll go back. You have to click on this load case, live load. Then you have to click on add. So this dialog box will show up. Go to member loads. Different types of loads. If you have a point load, then you will go to the concentrated force. Moments, uniformly varying. You have different load types here. So for now, we need uniform force. So what we'll do is we'll say -5. -5. 5 is the magnitude, that's 5 kilonewton per meter. Minus is in negative global y direction. This is y here. I want this in the downward direction, so I have to put a negative sign. Add, close. Now I have created that load in this load case. Now I want to assign. You can say assign to the view, or you can say if I select this beam, then it will show select, assign to selected beams. I will say assign, assign. Now I have assigned this load to the beam. I am almost done. What I need to do is now It is the analysis time. I'll go to analysis and print. You say I need everything. Add, close. Now you want to analyze it. Click on analyze, run analysis, save. See, there are no errors, no warnings. I'm done. Now I want to see the results. For that, you need to click on this post-processing mode. This will get activated only when the analysis is complete. Since we have already analyzed it, so we can click on it. We have a single load here. We say, okay. So these are your results. This deflection is activated. I can click it on again. I want to exaggerate it. You have a control and then zoom in. So it will, this is the exaggerated view of the deflected beam. We are in the isometric view, right? So the total deflection is, here are your summaries. This is the displacement, and all the displacement related quantities will be displayed on the right. So at node 1, there's a 0 deflection. At node 2, that's free end, minus 1.19. That's almost 1.2. Minus means negative. And what was our deflection? 1.2. So we are almost there. And I want to check the bending moment. For that, I need to click on reactions. Here, all the reactions get displayed. Bending moment of 62.5 kilonewton. Here also you can check bending moment of 62.5 kilonewton. And your analytical from beam bending theory, we have calculated bending moment, maximum bending moment of 62.5 kilonewton meter, and it's 62.5 kilonewton meter. So I hope if you want to draw the bending moment diagram, so you have to click on MZ here. This is your bending moment diagram. I can go to the front view like this. This is your bending moment diagram. If you want to display the values, so you go to result, view value, beam results. I want bending at the ends. Annotate. Now it says 62.5 kilonewton. Similarly, if you want shear force, for that you need to have a shear force diagram activated. This is your shear force diagram. Now go to results, view value, beam results, shear at the ends, annotate. So 25 kilonewton is the shear force. Total load is 25 kilonewton. 5 into 5, and then I hope this was just like when we are now going to analyze some frames, buildings subjected to different types of loads. This was just a trailer for that. Like I would like to recap what I did today. We modeled a beam, simply supported beam. First, we created a geometry of 5 meter. Then what we did was we assigned a section to it. We assigned this section to this beam. Then we created support, fixed support and assigned to this one of the nodes. Then finally loads. In the load cases, we defined and then assigned to this beam. Then finally we analyzed it and then we saw the results. I hope you liked it. You liked this video. We'll come up with now more advanced videos regarding analysis of columns, analysis of frames, and analysis of buildings, and subjected to different types of loads. And these loads may comprise of live loads, dead loads, seismic loads, wind loads. Even we'll be designing a water tank for water pressure. So we'll learn all those in coming videos. Thank you so much.